name is Marco Viceconti. I'm a full professor of bioengineering at the University of Bologna in Italy. My research interest the last 20 years has been in silico medicine. University of Bologna participate in Silico World with 3 units. My own department, the Department of Industrial Engineering, one of the medical departments, DIMES, and with a third-party organization, which is the Restoli Orthopedic Hospital. We are responsible for 2 of the 11 solutions, bone strength and force loss, which are focused on musculoskeletal diseases, which is where my expertise mainly lies. Then the colleagues at the department, DIMES, are working primarily in the area of machine learning and generation of synthetic data sets. The colleagues at the Restoli Hospital help us with the clinical validation of our musculoskeletal application. As an engineer, I see that virtually any other industrial sector is using modeling and simulation to improve the quality and the safety and the performance of products. And I don't understand why medicine is the only sector that doesn't. And we're not talking about trivial products, If you are developing a nuclear power plant or a large airplane transporting hundreds and hundreds of passengers, you want to be sure that these things are very safe, okay? But would you imagine that to test the safety of these products, we would just use them and see what happens? Because that's the way we test medicine. In clinical trial or this, we give the medicine to the patient and see if the medicine works or not. So that's my primary motivation. I think that there is a gap that needs to be filled. From long time, the barrier was the complexity of the human physiology and pathology. But nowadays, I think that with the advance of mathematics and computer science, I think we can take the challenge and develop predictive model of human health. It's complicated in the sense that in the preliminary analysis that we did in the In Silico World Project, we identified 6 barriers, to which I always added the 7th, which is the business model around In Silico Trials solutions. All these barriers are important on their own. So on one hand, we need better modeling technology because there are still many diseases for which we don't have reliable predictive models. We need more data and more high quality data to do validation. We need better defined and easier to push regulatory pathway to certify these in silico technologies. We need to communicate better with all the stakeholders, all the people who are somehow affected by this new technology, the patients, the doctor, the policymakers, the hospital managers, and so on. We need to explain better to these people what it means, this in silico revolution. And we need to educate the next generation of experts about this completely new paradigm. And then we have to make this technology efficient, economically viable, and build reliable business models. To do in silico trials, we need to have models that are able to predict for each single patient, so at the single patient level, quantities that are representative of the clinical outcome of the product that we are testing, whether a drug or a medical device. So that means that we need to develop a new generation of predictive models that can describe reliably the underlying physiological phenomena, the progression of the disease, and the effect of the treatment, again, whether it's drug or medical device. And this, of course, require quite sophisticated mathematical and computer science techniques, but also an extensive bioengineering work to demonstrate the credibility of these predictions. Overall, we have 11 solutions, and this solution target different diseases, different medical products, and they are at different level of maturity. What we want to do is to escort in these 4 years and during the duration of the In Silico World Project to higher level of maturity. So for some, this will mean to completely develop the model. For others, it means to finish the development, start the regulatory path, to complete the validation activities, and so on. The use of patient-specific models to inform the regulatory evaluation of medical products is something quite new. In medical devices, until recently, this methodology were limited to only a few preclinical assessments. And in the pharmaceutical area, even more, they were limited to preclinical evaluation and to some very specific activities. What we are suggesting now is that in silico trials, the use of patient-specific models can reduce, refine, and to some extent replace animal and human experimentation. Now, this is a big change with respect to the current practice, and so that means that we need to define completely new regulatory pathways in order to understand how to evaluate this model to decide if they are reliable enough, accurate enough, they can be used for this particular application. And this is a big work that involves experts like me in modeling, but also experts in regulatory science, authorities, clinicians. So it's a long and complex process.